The final three examples here will be showing distance time graphs. Here's a graph with three lines. We have three journeys. We have A, B, and C. Distance normally goes on the vertical and time is usually done on the horizontal, so time flows from left to right. Now if we look at this, we can see clearly that the journey A is showing proportionality because it's a straight line and it starts from the origin. So does B. B is also a proportionality graph because, again, it's a straight line going from the origin. C is not a proportionality graph because we have a straight line here which starts from 0, but then it changes angle and comes up here. Then it changes again and changes again. It's not one continuous straight line. So therefore, this C is not showing proportionality. If we looked at the speed, the higher or the steeper the gradient of the line, the faster the speed. So A, the person is traveling at a much faster speed than at B, and then obviously compared to C. You can use these graphs not only to look at speed, but we can also use these graphs to look at distances traveled. So for example, if we look at in A, what is the total distance traveled? So we go from the beginning, when the distance is 0, we go to the end, and we come across here, and the total distance traveled would be 250, and in this case meters. How long did it take them? Well, we look at the end of the journey for A, and we come down, it took them 50 seconds. So you can read off time, and you can read off distance off of any of these graphs. So if I wanted the, for B, the total distance traveled in B is 150 meters, and the total time taken was 60 seconds. Here we have another graph. It says that the graph shows the journey of a cyclist. He leaves his starting position heading east. And on the vertical, we have the distance from home, and on the horizontal, we have the time. Three questions, A, B, and C. The first part, A, says, how far has the cyclist traveled between points A and B? So A is here, B is here. So we go, well, how far has he traveled? He started at 0 meters, and he finished at 30 meters. So the total distance there would just be 30 meters. The second bit, he says, how far did the cyclist travel throughout his entire journey? Well, let's look at the journey. He goes from A to B, C, D, E, and then all the way back to F. F is at home. But the journey away from home was 80 meters, and then he cycled all the way back. So it's 80 meters from home and 80 meters back from home. So his total distance is 160 meters. Not a very big distance. Maybe, actually looking at it, this is probably miles rather than meters. But we'll stick with the M for meters for now. So his total distance will be 80 going there, 80 coming back, so 160 meters. Although possibly they mean miles. Let's have a look, part C. Describe the cyclist's speed between points C and D. So we can read speed off here, but look at this here, C to D. C to D is a horizontal line. So his distance did not change during that time. So therefore, if his distance isn't changing, he isn't moving. So therefore, his speed is 0. So he is not moving. So you would write that he is not moving, or he is stationary, is how we would say that. He is stationary. He is not moving. In this final question, it says the diagram shows a distance time graph for a motorbike. Work out the average speed of the motorbike during sections A, B, and the entire journey. So this time we're looking at speed. Speed we know is distance divided by time. The units here we have are kilometers and minutes. I'm going to keep it in those units just for simplicity's sake for this question. So we're going to do kilometers per minute as our answer. So let's look at part A, section A. What is the distance travelled? Well, section A starts at 0 distance and finishes here. So that's 25 kilometers. And the time it took is 20 minutes. So the speed will be 25 kilometers divided by 20 minutes, 25 divided by 20, put that into a calculator, and you get 1.25 kilometers for every minute. Now we'll look at section B. Section B is this section here, and section B, the distance starts at 25, finishes at 50, So the total distance traveled will be 50 minus 25, which is, again, 25 kilometers. So our speed is going to be 25 kilometers. How long does it take him for this section? Well, he starts at 30 minutes, finishes at halfway between 40 and 50, so that's 45. So the total time here is 15 minutes. So we have speed is 25 divided by 15. On the calculator, 1.67 kilometers per minute. It's actually 1.66666 and so on. We'll round it to 1.67. Now finally, for the entire journey. So that's from the beginning at 0 to the end at 50. How long does that take? And yep, that's 45. So we're going to do speed equals 50 divided by 45. And 50 divided by 45 to 2 decimal places is 1.11 kilometers per minute. Clearly slower than the other two because he stopped in the middle for 10 minutes. That would have a big impact on your final answer.